Right, so welcome to lesson 3 of organic chemistry on fractional distillation. So if you've got your booklets with you, turn to page 18 and you'll have a look at partway down, actually the knowledge check questions recapping the work from lesson 1 and lesson 2. So if you want to pause the video now and have a go at these, we can then go through them in a moment once you unpause the video. Right, so let's go through these and just get our answers out of the way. Name the two elements that make up hydrocarbons. So you should have hydrogen and carbon. Name the first 4 alkanes from the first lesson. Methane, ethane, propane, and butane. Then explain why alkanes are saturated. So they're saturated because they only have single bonds and all the carbon bonds are used up. So they're all bonded to something else. State the gas needed for combustion. Oxygen, O2. State the number of bonds a carbon atom can form. 4. Give the name of these types of bonds that carbon atoms form. They are covalent. And state where crude oil is found, sort of say in rocks or underground. And then what's the general formula for working out an alkane? So if you have the number of carbon, Cn, to get the number of hydrogen, you double the number of carbon and add 2. So CnH2n plus 2. Good. So on to the next page and we'll go through some of this text together. So first up, top of the paragraph. Now, to begin with, if you'd just like to pause the video and in the links below, have a look at video 1, just to introduce the idea of fractional distillation. Once you've done that and had a look at that video, unpause the video and we'll carry on reading through the text. Good, so hopefully you've had a look at video 1. So let's break down the text. Let's have a look at this first paragraph. So many of the fuels on which we depend for our modern lifestyle, such as petrol, diesel, oil, kerosene, heavy fuel oil, and liquefied petroleum gas, are products of a mixture of different sized hydrocarbons called crude oil. So first thing, make sure you've highlighted all of these different fuels that are produced from crude oil because you'd be expected to know examples of them. So obviously you know that petrol and diesel are used for cars and transportation. Kerosene is used as basis for aircraft fuel. And heavy fuel oil can be used to power ships and also power stations. Whereas liquefied petroleum gas, or for short known as LPG, can be used as bottled gases, often the type that you might take for a power camping stove, large scale that you buy at petrol stations and things like that. Now they are products of a mixture of different sized hydrocarbons called crude oil. Now remember, mixture is a key word because what that is telling you is that it's made up of different types of molecules that are not chemically bonded, which means that they can be more easily separated. So remember, different sized hydrocarbons, hydrogen and carbon molecules. So crude oil is a mixture of different sized hydrocarbon molecules. Now, let's carry on. The many hydrocarbons in crude oil may be separated into fractions, each of which contain molecules with a similar number of carbon atoms. By evaporating the oil and allowing it to condense at different temperatures, this is a process called fractional distillation. So, key word here is fraction. Now, a fraction are hydrocarbons of a specific length. So these are separated out from crude oil. Now, by evaporating the oil and allowing it to condense at different temperatures, a process called fractional distillation occurs. Just remember, distillation is the separation due to boiling points. And the key thing to remember here is that different fractions have different boiling points. Different fractions have different boiling points. Good, let's carry on a bit. So, many useful materials on which modern life depends are produced by the petrochemical industry. The fractions from crude oil can be processed to produce fuels and feedstock. So fuels, which are burnt for energy, and feedstock, which is the basis of these substances. So it's the basis of things like plastics, fuels, lubricants, solvents, detergents, cosmetics, perfumes, pharmaceuticals, flavourings. So if you think detergents, things like washing powder, cosmetics is the beauty industry, makeup, pharmaceuticals, medicines. So the vast array of natural and synthetic being man-made carbon compounds occurs due to the ability of carbon atoms to form similar compounds. Remember chains and rings from previous lessons. Good. Right. If we move on. So, if you have a little look at the next section below, what I would like you to do is in your own notes page, anything like that, have a watch of video 2. And just from it, pausing it where you need, make your own notes on what are the steps involved in fractional distillation. So if you could pause the video now and have a go at that, then we'll go through the next section of text. Good. If you've unpaused the video, let's have a little look at the next section of text and break it down. So, as it said, crude oil is a mixture of various sized hydrocarbons which are held together by weak intermolecular forces. Now, remember, these are what we describe as the forces between molecules. The larger the molecule, the more weak intermolecular forces it has, and therefore the stronger the overall attraction with other molecules. In the force diagram, you can see that molecule A has only 2 intermolecular forces, where molecule B, so this is A, this is B, has 10. More energy would be required to separate B than A. Good. So if you think of these as intermolecular forces, more forces equals more energy needed to separate them. Which means if you think about a larger molecule, a larger hydrocarbon, larger hydrocarbons need more energy to boil at a higher temperature. Good, let's carry on. Small hydrocarbons have low numbers of intermolecular forces, so it doesn't require much energy to overcome the total force and separate them. So it doesn't require much energy to overcome the total force and separate them. So, shorter chain hydrocarbons have lower boiling points. Large molecules require more energy to become gases. So, larger, it's the opposite. By heating all of the hydrocarbons in crude oil to approximately 350 degrees Celsius, they will all turn into a gas to evaporate. By letting them cool and condense slowly, they will turn back into a liquid at different temperatures and times, and therefore be separated by molecular size known as a fraction. So if we think about this, different fractions have different boiling points, and therefore in that respect they become gases at different times. So they become gases at different times when heated. Good. Hopefully you made those notes, and let's carry on. So, just to recap, distillation simply means to evaporate a liquid into a gas and then allow it to condense back into a liquid again. Crude oil is a mixture of different sized hydrocarbons which are held together by weak intermolecular forces. The larger hydrocarbon chains have more intermolecular forces, so require more heat energy to overcome and separate them from other molecules. This means that the boiling point of the hydrocarbon increases with size. That's an essential point there. Boiling point of hydrocarbons increase with size. The diagram below shows this process of fractional distillation. Read the following passage and use information to label the diagram correctly using words and arrows with support from your teacher. So, first thing I'd like you to do now is pause the video, and can you have a read of this paragraph? You might be able to do some of your own internet research as well and see how much of this fractioning column you can label independently using the information provided. Once you've done that, you can unpause the video and you can have a look at the labels that I add in and add in any extra information that you don't have, so that you've got a complete idea of how fractional distillation occurs. So pause the video now for me and have a go at that. Okay, good. So let's carry on. So you should have had a go at labelling this from the paragraph above and any extra information you've researched, but let's try and add in some information. So first up, down here, first thing to bear in mind is oil is heated and vaporized at the bottom of the column. So at the bottom of the column, it's around 350 degrees Celsius. Now, what we have is then we have our hydrocarbon vapors rising up the column. Now, bear in mind, we have around 50 degrees at the top. The temperature gets cooler as you go up the column. The temperature cools further up the column, which means the hydrocarbon vapors start to cool and condense into liquids when they reach their boiling points. So that means at this point, different hydrocarbon fractions of different length come out at different points as they reach their boiling points. So the fractions are removed and separated as liquids once condensed. So, fractions that you have come out are called residue, or sometimes you might see it called bitumen. We have heavy fuel oil. Further up, we've now got diesel. Then we end up with kerosene. Then we end up with petrol. And then we end up with LPG. So temperature is kind of at which these come out and condense. You're looking at about 80 degrees here. You're looking at about 130 degrees here for a boiling point. You're looking at around 260 degrees Celsius here. And down here, you're looking just below about 350 degrees Celsius. Now, key thing to bear in mind that as you go up the column, the hydrocarbon fraction lengths decrease. So, up the column, length of the hydrocarbons decrease. Okay. Now, with that, there comes other properties that you can discern about the hydrocarbons. So, down the bottom, you have long hydrocarbons, and because they are long, they have a high boiling point. They have a low flammability, so they're hard to set on fire and combust because of their high boiling point. They're really viscous, so that means they're really sticky, so they have a high viscosity. So, for example, bitumen is used to make road tar. And if you've ever seen a road being laid, you know how thick and sticky tar is when it's first put down. Whereas up the top, you have short hydrocarbons, and these have a low boiling point, high flammability, and a low viscosity. Good, right. We've got those notes down. Turn over the page, and there are some questions I'd now like you to have a go at. So, pause the video, have a look back through your notes, have a look over any internet research that you want to, have a go at these questions, and then you can unpause the video for us to go through it, okay? Good, so, identify where crude oil vaporizes. So the bottom of the column. Name the processes that happen to hydrocarbons before they pass up the column. 1, they have to be heated. And 2, once they're heated, they are vaporized. So, explain why fuel oil is found at one end of the column and the natural gas found at the other end. So they're different sizes, they're different sized hydrocarbons. So therefore they have different boiling points. And also, they have different densities. So because you have shorter chain hydrocarbons made up of fewer atoms, they rise higher. Explain why some hydrocarbons are gases and others are liquids at the same point in the column. So it takes different amounts of energy to break bonds. To break bonds in long and short chain hydrocarbons. With that, that means they have different boiling points. So therefore, some are gas and some are liquid at the same temperature. And then explain why further separation may be needed in some of the fractions. That's because it's not 100% accurate a process. There still needs some level of refinement afterwards. Good. Well, turn over. Now, exam question. Okay, so if we go through this together. The hydrocarbons in diesel are bigger than the hydrocarbons in petrol. Compare the physical and chemical properties of diesel and petrol. Okay, so a couple of things that I want you to do. If we're going to model the answer to this question, when it's compare, bear in mind we're looking for similarities versus differences. So we can do this as a table. So we're at petrol, diesel. And we can compare some properties. So what do we know? Hydrocarbons in diesel are bigger than hydrocarbons in petrol. So let's go with length of chain. What are the properties do we know as a result of that? Boiling point. Flammability. And then the other property that was key to try and remember, viscosity. So, length of chain. Hydrocarbons in diesel are bigger than hydrocarbons in petrol. Means we have longer and shorter chains. If this is longer, it's got a higher and a lower boiling point in comparison to each other. What about the flammability? If it's got a higher boiling point, it's got a lower flammability, whereas if it's got a lower boiling point, it's got a higher flammability. If it's a longer chain, it means it's got a higher viscosity, it's thicker. Whereas if it's a shorter chain, it means it's got a lower viscosity because it's thinner. Good. Little example of how you can model and carry out an exam question really easily, and you'd still get 6 marks because you've compared similarities and differences for each of them. Good. Last little section. So, pause the video and have a look at video 3 for me now, okay? Make any notes that you want and have a go at the exercises within it. Once you have done that, we'll go through this last paragraph. Good. So hopefully you've unpaused the video and you've had a go at video 3. So let's break down some of this information. So, the Earth naturally produces fossil fuels as a means of storing carbon to reduce the amount of CO2 in the atmosphere. What are the fossil fuels that we need to know? Crude oil, natural gas, and coal. They all contain carbon. We call this carbon capture. Since the Industrial Revolution and the ever-increasing demand for energy, fossil fuels have been the desired choice to meet our energy requirements. Now, how do we get energy out of them? We burn for energy. And what happens as a result of that? When we burn for energy, they release trapped carbon to bond with oxygen and make CO2. So, they are readily available, versatile and high in energy. Many industries rely on these fuels not just to source energy, but for versatility of their byproducts of their other materials. So remember, we called that feedstock. That was used to make things like plastics. The combustion of fossil fuels provides the heat that is used to produce steam, which powers a turbine in a power station producing electricity. Remember, combustion we describe as burning in oxygen. The energy industry is now realising the environmental impact of fossil fuels, climate change, increase in CO2 and global warming, air pollution and destruction of ecosystems. So, remember, increases CO2 in the atmosphere. What does that do? It traps heat. And the trapping of heat brings about consequences associated with global warming, which you'll have seen if you watch video 3. There are 4 main consequences that you need to make sure you are aware of climate change. Now, clearly the products from oil are useful, but humanity now has to explore other sources of energy. You might see these referred to as renewable energy. Wind, solar, tidal, geothermal, hydroelectric, to meet the demands of an ever-growing population and reduce the negative impact that this has on the environment. So if you weren't sure of that paragraph, make sure you have watched video 3, okay? Because that will make it a lot clearer to you. Right, last bit. Pause the video now and have a go at the knowledge and application questions to finish for me, okay? Good. Hopefully you have had a go at the knowledge and application questions. We will pause the video. So let's go through the answers to finish. So, 4 uses. You can incorporate any of the uses from fuel and feedstocks, naming the fuels kerosene, petrol, diesel, naphtha, LPG. Feedstock, we produce lubricants, solvents, detergents, cosmetics, pharmaceuticals. They all come under the headings of these. Okay, so make sure you know that. Two families of carbon-based molecules, alkanes and alkenes. Name the force found between molecules. Remember, we call these intermolecular. Where's the coolest part of the fraction column? It's the top. What happens to substances at their boiling point? They evaporate. We might say that they vaporize. Define the term fraction. So it's a hydrocarbon of a specific length. Find the term synthetic, man-made. Name the harmful waste gas from combustion of alkenes. When we've talked about combustion before, the harmful one to us we call carbon monoxide. Explain using the term intermolecular forces where different sized hydrocarbons have different boiling points. So, for example, longer hydrocarbons, they have higher intermolecular forces between them, which means they need more energy to break. Obviously then vaporize, which means they have a higher boiling point. Explain how the production of fossil fuels is a way of the Earth reducing the levels of CO2 in the atmosphere. Natural carbon capture. They're a store of carbon. And then finally, explain how the temperature gradient in the fractional distillation column helps to separate various fractions. Different length hydrocarbons have different boiling points, therefore they condense at different temperatures. Good, and that's the end of lesson 3.